In this tutorial, I'll show you how Mercenter uses the cost structure in combination with the product configuration to determine the selling prices of the products. This is an advanced topic that is aimed at senior sourcing professionals who are responsible for implementing their organization's sourcing strategy in collaboration with suppliers. If you are a cost structure user, such as a buyer or supplier, we recommend that you check out our tutorial on product management. In order to follow along, you'll need to be really comfortable with attributes, resources, and cost structures. If this is not the case, then please complete those tutorials first before continuing. Here's what we'll cover in this session. First, I'll show you how to tailor the cost structure to the unique characteristics of the product in a process called product configuration. With configuration out of the way, we're ready for a look under the hood at the inner workings of formula generation. This is a complex subject, but something you'll need to understand if you'll be designing and troubleshooting your cost structures. Then I'll show you how the selling prices are actually determined in a process we call roll-up. Once you're armed with the theory, Natasha will build upon an earlier tutorial where she built the cost structure for a fictional sheet metal fabrication agreement by configuring and costing a product. After the demo, I'll explore what happens to the product costs when changes are made to the agreement. When a product is added to an agreement, you can tailor the implementation of the cost structure to meet the unique specifications of your product through a process we call product configuration. This topic is the subject of this section. But first, let's define some terms. A cost item is implemented in a product cost as a product cost item. Collectively, I'll refer to this hierarchical arrangement of product cost items as the product cost structure, or simply the product cost. Now, let's discuss the configuration process. When you add a product to the agreement, Mercenter automatically implements all mandatory top-level cost items. This process is recursive, so if any of those implemented cost items also have mandatory children, then those will be implemented automatically as well. Suppose we have a cost structure which has painting and packaging cost items at the top level. Let's say that painting has a child cost item called coat. If both the painting and coat are mandatory, then when you add the bicycle to the agreement, Mercenter will automatically implement the painting and coat cost items, but not the packaging. Once the mandatory cost items have been implemented, it's up to the configurer to customize the product cost so that its price can be calculated. Configuration involves three activities: setting product cost attribute values, deciding which cost items to implement, and setting product cost item properties. Let's discuss each of these activities in turn. Once a product has been added to the agreement, your first job will be to set the values for the product cost attributes. These attributes usually require information specific and global to the product, such as its part number or number attributes used in the formulas. I won't dwell any longer on this topic since you should already be familiar with attributes. As mentioned earlier, if a cost item is mandatory, it will be automatically implemented when its parent is created. By designating a cost item as non-mandatory, the designer has stated their intention that this item of cost is optional for the product. If you don't implement it, then it won't be factored into the calculation of the selling price. Continuing with the painting example, it's clear that the designer's intention was that packaging is optional. So for the bicycle, I've decided not to package it. Irrespective of the designer's implicit intentions, the designer should always provide a clear purpose for each cost item through its name and description fields to ease your decision-making. Actually, there is a caveat. Not all non-mandatory cost items are optional. That's because even though a cost item may be non-mandatory, if it's used in a formula expression in conjunction with another cost item which has been implemented, you will also need to implement the dependent cost item. Mercenter's UI will notify you of the dependency so that you can resolve the warning. To show you what I mean, let's say that the coat cost item is non-mandatory, but the formula for the painting cost item takes the coat cost and multiplies it by a material loss factor attribute from the painting cost item. Since the painting product cost item exists, you will also need to implement the coat, even though it's actually optional. Something to be aware of. Once you've decided to implement a cost item, or it has been implemented automatically, its name, description, and order are automatically copied to the new product cost item. It's advisable to change these to something more aligned with the reality or specifications of the actual product and rearrange them to follow a logical order. The name must be unique among its siblings, but the description is optional and doesn't need to be unique. Once created, these properties are no longer linked to the original, so any changes made will persist. When a cost item is repeatable, you'll be able to repeat it an unlimited number of times. By allowing this, the cost structure designer has stated their intention that this item is a repeated material, operation or process. When you repeat them, the repeated costs are factored into the product selling prices, as you'll soon see when we cover formula generation. Suppose the painting cost item have coat and print cost items as children. By setting these to repeatable, the designer has indicated that multiple coats of paint and printing steps are possible. Let's implement 3 paint coats and 2 print operations in our bicycle product. First, notice that the order initially follows the cost item order. Second, you can see that Mercenta has automatically appended a suffix to their names to maintain their uniqueness. To tidy this up, the first thing I'll do is rename them to reflect the physical processes that they actually represent. In this case, base coat, top coat, and gel coat. The printing steps are back print and screen print. Secondly, I'll reorder them to follow the progression of operations. First the base coat, then top coat, then we'll apply the decorative back print, followed by the gel coat, and finally, we'll screen print on the brand. In addition to its name and description, each cost item also has 2 sets of information, the product cost item attribute values and resource items, that you'll be able to set depending on whether they are defined or present in the formulas. If the designer has defined a product cost item attribute for the implemented cost item, then you'll need to provide its value. Because the entity for these attributes is the individual product cost item, these values are independent of each other even though their cost item might be the same. In the painting example, suppose that the designer has defined a coating weight product cost item attribute for the coat. In our bicycle, you could enter 200 GSM, 150 GSM, and 200 GSM for the different coats independently of each other, and these would be used in the calculation of the selling prices. If the designer has used a resource item attribute in a cost item formula and you implement that cost item, then you may need to choose the resource item to use for each instance of the product cost item. I say may because you won't need to if the attribute is used in an expression which isn't implemented. If you want to know why, then you'll have to listen to the formula generation topic coming up next. In the example, if the formula in the code has an expression which uses resource item attribute called price for the applicator resource, then you would need to select the resource item in each of the implemented codes. In this case, I've selected automatic for the base coat, robot for the top coat, and manual for the gel coat. Finally, you can of course remove any product cost item except if it's mandatory and it's the last one remaining. In the example, suppose the code is mandatory. I can remove 2 of the codings. But since the base code is the last one remaining, I can't remove it. Another thing that you need to bear in mind is that if you remove a product cost item, then all its children will also be removed. The next topic that I want to discuss is formula generation. This is an advanced topic, but as the cost structure designer, it's important to understand the inner workings of formula generation because it will help you to design and later troubleshoot when things go wrong. When the product cost item is created, Mercenta combines the cost item's formula along with the attribute values that were selected or you've specified to generate a formula for the new product cost item. The attribute values provide the real numbers that will be used by Mercenta to calculate the value of the product cost item and ultimately the price of the product. To learn about formula generation, I'm going to use examples based on the cost structure shown here. Let's assume the formula for the parent cost item uses product cost item attributes from itself and children which I've labeled A, B, C, and D. These attributes could be the special formula result attributes we talked about earlier or custom ones. The attributes I've labeled Z are either agreement, resource item, or product cost attributes. It's not important what they are for now. Before I get into how this formula would be generated in the product cost, I'll need to introduce the concept of the formula segment, which will help me explain what's going on. A formula can be divided into a number of segments. Each segment is delimited by either a plus or minus operator. So for the formula shown here, there are 4 segments: Z, AZ, BZ, and CD. Not every segment is necessarily generated, or indeed, only generated once. This might sound counterintuitive, but let me illustrate how this works through examples. I'll add a product to the agreement and implement cost item A. By default, Mercenter will generate every segment, except if it contains an attribute for a cost item that hasn't been implemented. You can see here that segments BZ and CD were not generated because their cost items were not implemented. Only 2 segments are generated. The first segment doesn't contain an attribute for any cost items, so it's generated by default. The second segment is generated because A exists. It is in fact itself. Hopefully you're following me up to now. Let's now look what happens when we repeat B. When you repeat a cost item, the segments that contain the cost item's attributes are also repeated. In more complex situations, if a segment contains multiple cost item attributes which are repeated, then Mercenter generates all segment combinations of the repeated product cost items. In mathematics, we call this the Cartesian product, which I won't delve into here. This scenario is dealt with in the documentation if you want to dive in deeper. Next, let's look at what happens in the case where a segment contains attributes from different product cost items. If one exists, Mercenter will display a warning that the other product cost item must be created in order to complete the segment. To show you, when I create C1, a warning is displayed indicating that an implementation of D is missing. Now that you know what causes a segment to be generated and where Mercenter gets the product cost item attribute values from, let's now look at the other attributes which I've labeled Z. If Z is an agreement or product cost attribute, then Mercenter already knows its attribute value because there can only be one agreement and one product cost for the current product. Let's say that the first Z is an agreement attribute and the second Z is a product cost attribute. If their attribute values are 3 and 5 respectively, then Mercenter will simply use those values in the generated formula as I've shown here. On the other hand, for resource item attributes, Mercenter can't decide which entity to use because there may be multiple to choose from. In these cases, the user will need to select a resource item for the formula generation. In the example, if Z is a machine resource, the product cost will initially be in an error state because Mercenter doesn't know which resource item to use in the generated formula. If we select machine 2, then the attribute value is obtained from the chosen entity and the formula can be generated. Using resource item attributes in your formulas is the most intuitive way of customizing your products because it feels closest to the way that a bill of material works. In plain English, you're saying that this product uses machine 2 in its manufacture process, whereas another product uses a different machine. After learning about how the formula for each product cost item is generated to calculate its value, let's now explore how the product cost structure is rolled up to determine the selling price of the product. Mercenter always maintains internal consistency between the cost structure, the product configuration, their dependencies, and the product prices. As a result, the product costs are continually recalculated or rolled up to ensure that only valid and up-to-date prices are always displayed. Conversely, if there are any errors in the cost structure or configuration, the product costs are invalidated to ensure that an invalid price is never displayed. Mercenter only recalculates the product costs that are affected by changes to the agreement. For each affected product, Mercenter starts with the lowest level product cost items and executes their generated formulas to determine their values, working upwards until it reaches the top level. The price of the product then is simply the sum of the values of these top-level product cost items. Although rounded values are displayed by the portal, Mercenter actually never rounds values for any calculation step. If an error occurs during the roll-up, the cost calculation stops for that particular product and its cost is invalidated. While any successfully processed product cost items will display correct values, the one that caused the error, as well as any higher up the hierarchy and the product itself, will display alerts. It's worth noting that this doesn't impact other products, which will continue to roll up normally. However, if any product wasn't rolled up successfully, you won't be able to submit a proposal for approval. During the roll-up process, 2 types of errors could occur. The first type is easy to identify because Mercenter will highlight the offending product and product cost item. This error could be due to incorrect configuration or a math error, such as a division by 0. In most cases, Macenta will provide a reason for the error, making it easy to resolve. Common causes of this type of error include forgetting to select a resource item or using an attribute value of 0 in a formula. When these errors occur, you won't be able to submit the proposal for approval. The second type of error is more concerning because the roll-up will appear successful, but the prices may in fact be incorrect. The only way to know that there is a problem is to compare the expected prices with the calculated results. These errors may be caused by incorrect configuration or, in the worst-case scenario, a flaw in the design of the cost structure. Often for these types of errors, viewing the generated formula so you can see the real numbers used for the calculation will greatly help with troubleshooting. Natasha will show you how to do that shortly. Macenta won't stop you from submitting the proposal for approval when these errors occur, so it's essential for the parties to audit all prices before accepting a proposal. That's all for product configuration. Natasha will show you more in the demonstration, which is coming up next.
Thanks, William. In this demo, I'll show you how to configure a sheet metal part using the cost structure that we designed in the Designing Cost Structures tutorial. You'll know that the cost structure is complete and valid because the final unit of measure is displayed in the proposal menu and highlighted in green. This unit of measure is the unit for the selling prices of the products under this agreement. The product that I'm going to add and configure is a frame support consisting of two separate transfer stamped parts, which will be MIG welded together. Both parts require multiple steps, starting from cut sheet, then stamping, followed by degreasing and finally welding. The first part, the frame, will have 3 transfer steps, and the second, the support, has only 2 steps. Right, let's get started. The first thing we'll do is add a product to the agreement. From the proposal menu, click Product Costs in the Agreement section. Notice that the buying parties are listed here. Currently there is only one party, Neptune. To add a product to this agreement from the party, click the plus icon to the right of the party. Then choose the only product listed, the frame support. Then click the Add button. Once Macenta has added the product, click it to load its product cost. I'm not going to spend a lot of time on agreement products, because this is covered in a lot of detail in our tutorial on product management. The purpose of this demo is just to show you how cost structures are actually implemented once designed. Before we start implementing the cost structure, I'll orient you on the layout of the form. At the bottom of the form is the product configuration area, where we'll be spending all of our time today. There are a few things to be aware of here. First, notice that the stamping and step-end cost items have been implemented for us automatically. That's because they are mandatory. Second, you can implement cost items for the top level by selecting them from the drop-down at the top, but it's disabled now because there's only one top-level cost item, and this one is not repeatable. You can also implement cost items by selecting them from the parent. Finally, you can't miss the fact that the price is empty and highlighted with an error. That's because the product cost items are also in an error state, so Macenta can't roll up the product cost. Let's first tidy up the top-level cost item. Click the stamping link to load the properties dialog. Then I'll key in a more helpful name and description. This product cost item doesn't have any attributes, nor does its formula require us to choose any resource items, so there is nothing more to do here. Oh, one more thing before I go, notice that the delete button is disabled. It can't be deleted because the cost item is mandatory. Click Save to return back. First, let's add the production process for the frame. Since Step N has been implemented already, I'll click it to show its properties. First, I'll tidy up the name and description. You should personalize these as much as possible so that other users will know what's going on. This cost item has 2 product cost item attributes, productivity and quantity, which are marked with a tag icon. I'm okay with the default quantity, but I'll increase the productivity loss a bit. Below the attributes, you'll see that we need to select items for the three resources: the tool, scrap, and machine needed to produce this semi-finished part. I'll set these. And then click the Save button to save the changes and return back to the product cost. When we return back, notice that Macenta has used the configuration we provided to regenerate the formulas and update the product cost item prices, as well as the final price of the product. But we are still not done yet. Let's continue. Because this is the last step before we send the parts for welding, we'll need to remove lubricating oil from the part. Choose Degrease from the Step 3 parent. When the product cost item is created, its edit form will automatically open for editing. Again, I'll tidy up the name and description. I'll input a speed of 200 pieces per hour for the production speed. And we are going to use the continuous degreasing machine. Then I'll save my changes. That's the last step done. Next we'll implement Step 2. Choose the Step N-1 cost item by selecting it from the Step 3 parent. When the form loads, I'll input a helpful name and description, and choose the tool, scrap quality and machine. This step will be produced on a 50-ton mechanical machine. I'm going a little faster now because you've seen me do this already. Finally, I'll add the first step. This time, select and add the Step N-2 cost item from the Step 2 parent and then set its attributes and resource items. That's the 3 steps done, but notice that Macenta has automatically implemented the Sheet N-2 cost item because it's mandatory. We made it mandatory because the first step must use steel sheet. Click the sheet and key in a helpful name and description. I'll set the loss factor to 6% and choose one of the galvanized sheets from the sheet resource. Then click Save. That completes the frame. You can see that the sheet progresses through Step 1, Step 2 and Step 3, and finally degreasing. For each product cost item, its value is calculated according to the cost structure and the configuration, until we finally arrive at the cost of the frame. But we are not done yet. Let's now add the support component. Select and add the Step N cost item under Frame Support. This is the second time that we've implemented Step N. We can do this because this cost item is repeatable. I'm going a lot faster now. Again, we'll need to degrease. So I'll add degreasing and set its properties. Then I'll add the upstream step, Step N-1, which I'll call Step 1. Again, this support will use one sheet, which will be consumed by the first step. Select and add the Sheet N-1 cost item. Then I'll configure it as I did before. Finally, now that the 2 parts are stamped, let's weld the frame to the support. Under Frame Support, select and add the Assembly cost item. When the form loads, I'll update the name and description, and then input a cycle time of 26 seconds per part and choose the welder as the labor type. That completes the configuration of the frame support. You can see that the price has been calculated by adding together the costs of the 2 parts plus welding, to arrive at a final product cost in accordance with the agreement's cost structure. The generated formulas for each product cost item can be viewed by clicking the price, in case you need to verify that the prices were calculated correctly, as you should. Here you can see that the previous step formula result is added to the cost of stamping and then offset by the offcut recovery. You can also see that real numbers have been taken from the attributes and the resource items that you selected. Hopefully, I've demonstrated how easy it is to configure and cost products once the cost structure is designed. I'll say my goodbyes now and hand you back to William for closing remarks.
Thanks, Natasha. After the demo, you might be wondering what happens to the product costs when changes are made to the agreement, given the tight integration between the agreement's properties and the product pricing. As I said before, Mercenter always ensures that the agreement is internally consistent at all times. This means that the product pricing always reflects the current state of the agreement. It's impossible to have a situation where, for example, a product uses a resource item that doesn't actually exist. To maintain internal consistency, Mercenter may automatically modify the cost structure and product costs when changes are made to the entities they depend on. The changes that occur and the actions taken by Mercenter depend on the type of change being made. If it causes the cost structure or product costs to be invalid, we will display appropriate warnings. But don't rely on warnings. It's always good practice to individually review all product costs whenever you make any substantial change to the agreement. While it may be obvious that direct changes to the cost structure, such as modifying its hierarchy, properties, or formulas, will immediately affect the product costs, it may not be immediately apparent that certain indirect changes can have significant impacts as well. For example, removing resources, resource items, or altering any attributes can also trigger cascading changes throughout the product cost structure. I won't cover specific scenarios in this tutorial because you can find detailed information about the different types of changes and how Mercenter ensures consistency in the documentation at Mercenter University. On that note, we've reached the end of this tutorial. Before you sign off, let's quickly recap the key topics we covered. We started by introducing product configuration, which involves customizing the implementation of the cost structure to match the unique characteristics of products. Next, we peeked under the hood by examining how the configuration process affects the generation of the formulas which determine the value of the individual product cost items. Then we looked at product cost roll-up process which determines the selling price of the products. Finally, we examined the tight integration between the cost structure and product costs, highlighting that maintaining internal consistency may require Mercenter to make automatic changes to the configuration. We certainly covered a lot of material, but by now you should be well equipped to effectively use cost structures to configure and cost your agreement's products. Goodbye and happy configuring!